Welcome to day one of Big Data Hadoop course. The day one will be very basics and we will be seeing how the big data started. So the chapter name can be called as Introduction to Big Data Hadoop, or it is more of introduction to what is big data. What exactly is big data? So let us start with very basics of data or IT. The very basic is called as a bit. So whatever is stored in a database or anywhere, it is stored in terms of bits. And bit is nothing but a single value. It can either be a 0 or 1. So it is a single digit value that can have a 0 or 1. Then after bit it comes bytes. Bytes is nothing but 8 bits. The example can be anything, combination of any zeros and ones. So you can say it 001 1000. So this is called as a byte. Then comes kilobyte, KB, that is kilobyte, KB. And kilobyte is nothing but 2 raised to 10 bytes, which is equal to 1024 bytes. 2 raised to 10 is 1024. And let's approximate it to 1000, or let's approximate it to 10 raised to 3 bytes. So for easier calculation, I will say 10 raised to 3 bytes, just an approximate value. So 1 KB is nothing but 10 raised to 3 bytes or 1000 bytes. Then let's go to megabytes. So megabyte or MB. So MB is again equal to approximately equal to 10 raised to 3 kilobytes. After megabytes comes gigabyte, represented as GB, and it is again approximately equal to 10 raised to 3 megabytes. After gigabyte comes terabyte, that is TB, and it is equal to 10 raised to 3 gigabytes. Then comes petabyte, represented as PB, and is equal to 10 raised to 3 terabytes. After petabyte it comes exabyte, represented as EB, and it is approximately again equal to 10 raised to 3 petabytes. So when we talk in terms of big data Hadoop industry, most of the times our system or the cluster will have terabytes and petabytes of data. So let's say if someone is asking you what is the data that you're working on, you will be typically working on few hundred terabytes of data or petabytes of data. So this is the reason this basics is also important to know. Then to give you just a glimpse of what is the size of the data that we use. Let's say if I am using a hard disk in my laptop is having a hard disk of 1 terabytes. So this is the capacity of my personal laptop hard disk. Again, if I take example of my mobile device, the mobile device storage is 128 gigabytes. If I take an example of a photo, if I take a picture in my mobile, it takes around 10 to 15 MB, being a dual camera, so it will take a bit high amount of data. So a photo will be around 10 to 15 MB. So this is the typical size of the things that we use daily, a hard disk or a mobile device or a photo and so on. Let's go ahead. Now currently the data is exploding. Data is exploding. When I say data is exploding, what I mean over here is the rate at which the data is being generated is very high. the rate at which the data is being generated is very high. As per IDC, the curve is something like this, and over here is around 40,000 exabytes, and it is expected to hit 40,000 exabytes by 2020, and 2010 was somewhere over here, 10,000 exabytes, 20,000, 30,000. So this is my graph, maybe midware is 2015. So this is my graph, and we can see that as per this graph, the data is increasing exponentially. There are various reasons for this data to increase by such a high extent. We'll be seeing what are the different reasons that the data is increasing so fast. 2010 it was somewhere over here, but 2020 it is touching 40,000 exabyte. So let us try to understand what are the reasons that are causing my data to increase at such a high rate. Let us compare the data that is generated over the internet. So let's see what is the data that is being generated in internet. Internet data generated every minute. Let us compare the data that is generated in last 2 years, and let us try to understand how the data has increased from 2016 to 2017. Let us take example of few of the commonly known things that we use almost all the time or most of the time in a day. So WhatsApp, Google, then Facebook, Uber to take cabs. Let us take example of these commonly used platforms and how much data it was generating in the year 2016 and 2017. Let us compare. So WhatsApp was having approx 20.8 million messages that was exchanged every minute in 2016. So we are talking about every minute. So every minute there were 20.8 billion messages in 2016, which grew to 29.2 million messages in 2017. So we can see that from 20 million approx, it went till 30 million. Similarly, Google, as the data that was generated by Google, the number of searches that were done every minute was 2.4 million. So 2.4 million search queries were run every minute in 2016. That increased to 3.5 million search queries every minute. Similarly, let's take example of Facebook, which says that 701,000 logins took place every minute. So it was around 701,000 logins every minute, and it increased to around 854,000 logins every minute. So many users have increased from 700,000 to 854,000 users logging in every minute. Then let's take an example of Uber. In Uber, around 1389 Uber rides were taken every minute, and it increased to around 3833 rides every minute. So we can see the amount of data that is generated for each of these websites or platforms has increased tremendously. So this is the amount of data that has increased for each of these platforms: WhatsApp, Google, Facebook, and Uber. Let's see the next thing, that is called as a three V's of big data. Three V's of big data. This is very important. what are the 3 weeks of big data. Wherever you're learning or whenever you're starting to learn anything about big data, there's the first terminology that will come to you and will be the common for every courses or wherever you refer to. So the 3 V's of big data are volume, data volume, data velocity, and data variety. 3 V's of big data are data volume, data velocity, and data variety. Let's try to understand what are all these 3 V's. Let's start with data volume. Data volume can be calculated in MB, GB, TB, petabyte, and so on. So to understand how the data volume has increased, let's take an example. Let's go sometime back in history. We are looking into how the data volume has increased. Let's go back sometime where you were having let's say VGA cameras or 1.3 megapixel cameras. So all these cameras were generating less amount of data, or whenever you click a photo, the photo will be around, let's say, around 500 KB or 600 KB and so on. But at the current time, when we are talking for dual camera, triple camera and so on, or 12 megapixel camera plus one more 5 megapixel camera, let's say a dual camera, if you take a photo by this one in a good resolution, the photo will be, let's say, approx 15 to 20 MB. So the same photo, if you are clicking sometime back using VGA or 1.3 megapixel camera, it was just in KBs. But now the same photo is in MBs. So like from KBs, it jumped to MB. Similarly, if you take an example of recording a video as well, previously the video quality was not that good. So let's say it was taking around, let's say video was previously taking around 700 MB of data. And let's say now you decide to record the same video using 4K and full HD, 4K and so on, new things coming up. So the same video may take around 7 to 8 GB of data. So we can see that MB has increased to GB. So similarly, whatever you are doing, the let's say you're clicking a photo or you're making a video, the size is just going on increasing. So this is my first V, that is called as a data volume. The volume of the data that is getting generated has increased. Also, multiple users, multiple people have started using the system, which has also increased the data volume. Then let's go to the next thing, that is data velocity. For data velocity, the previous days, olden days, there were only, let's say, batch jobs. So what have used to happen is a list of jobs were running, let's say only in the night, every night a job will run and it will get a data from some other system. So the data was generated in batches and it was coming very less. Then from batch it became periodic. That is, in periodic the data will be coming, let's say every 1 hour, every 2 hour or something like that. So this is called as a periodic data generation. After periodic, it became near real time. That is, as some transaction happens or something happens in a system, the other system will get the data near real time, maybe within few minutes, or it can be seconds as well. And currently the data is real time. If I'm making a video call, audio call, the data is being recorded, all this data is being generated real time, transmitted real time and so on. So with time, it went from batches, that is every night, to periodic, let's say every 1 hour, to near real time, that is whenever something happens, the data will be pushed to another system. And real time means as and when that particular thing is happening. Let's say a transaction has happening on a credit card or a debit card or an account, the data is being transmitted on real time. So the velocity is increased. Velocity can be defined as speed at which data is generated. So this is the second V, data velocity. Let's go to third V, that is data variety. For data variety, previously you were having only tables. Tables look something like this. It is a structured thing just like your Excel, the Excel that you use. So this is called as a table. There will be columns, roll number, name, standard, and so on. So previously the data was only in the form of tables. As the data grew, it became databases. So it was a database. As the time goes ahead, it further increased to photos. So like you are having photos, it increased to web, audio, and so on. And going forward, if you see today's world, the data is generated enormously by social media, videos, lot of unstructured data. Mobile devices are generating a lot of data, and so on. So these are the different things that are generating a lot and lot of data. So the variety of the data that is generated is also increased from tables, that is from structured data, increased to database, then increased to photos, web, audio, then increased to social media, video, unstructured data, and mobile data, data that is generated from mobile. So the data that is generated has increased. These are the three V's of big data. With time, different V's came into picture like veracity, value, and so on. So people started adding more and more V's, but these are the basic three V's of big data. Then let's see about what are the trends in big data, what the market says about big data, trends in big data. Gartner research says that around 75% of companies have already invested in big data or will be investing in next 2 years. 75% of companies are investing or planning to invest in big data in next 2 years. Gartner's is a research firm, and as per their research, it says that 75% of the companies are either currently investing in a big data or will be investing in big data in the period of next 2 years. IDC says that the growth of big data industry is 12% per year, and the approx IT industry growth is 2% per year. So IT is growing at this rate and big data is approximately growing in this rate. So this is the rate at which the data or the industry, big data industry is growing. These are the salary trends in big data, and this we have taken it from glassdoor.com, and it's from the World Economic Forum. So what are the best jobs in the world and what are the salaries that they are getting considering the work life balance? So it is in US dollars. Our data scientist gets around 114,000 US dollars. A search engine optimization manager gets around 45,000. A UX design, user experience design gets around 90,000. Software QA engineer is getting around 90,000. Solution engineer is getting around 92,000 of the salary. So the people who are working on data, let's say working as a data scientist role, they are getting around 114,000 of salary, US dollar salary, and which is the highest as you compare with the other professions. Now let's see the flow of big data. The data that is coming, it either comes in a real time or comes as a batch processing. So I will say either the data is coming as a real time or it is coming as a batch processing. Again, the data that is coming, it can either be a structured data, that is, it will have a definite structure, or it can be unstructured data. That means it doesn't have any structure, you have to figure out yourself. The data that is coming from different sources. Let's say it is coming from your mobile devices, it is coming from banks, it is coming from cars, it is coming from aeroplanes. All these things are generating a lot of data. There is IoT also that is coming a lot in market. So internet of things, the things that you use at home and other things will be connected to internet. Like in future your clothes can be connected to internet, your TV is already connected to internet, maybe via Android box and so on, or a Chromecast and so on. Other devices also, like your cleaners, robot cleaner and so on, these all device, your washing machine, your fridge, and all these things are going to be connected soon or sooner or later to internet. So all these things are doing nothing but generating a lot and lot of data. Once this lot and lot of data is generated, it is fed to the next system, and over here we take care of the privacy. So let's say there is some social security number or an IC number or some critical data like Aadhaar card number, whatever number is there. If that number is there, we cannot store it directly. Similarly, let's say your credit card number is there. So all this data you cannot store directly. If you store this directly, it is a chance that someone else can steal this data very easily. So what company usually do is, instead of storing this critical data directly into the system, they encrypt the data. So they will be encrypting the data and storing into the system so that the other things cannot steal from database, and if they want to use, they have to decrypt the data first. An encryption key is hidden and so on. If encryption is not possible for some reason and data is not much required, so the data can also be masked. That is, the data can be hidden. It cannot be uh, it is hidden completely, so it is scrambled and kept. If it is masked, you cannot recover the data. So either it is encrypted or masked depending on the requirement of business. Then it goes to pre-processing. Let's say if it is unstructured data, you want to convert it into a structured data, or some other pre-processing you want to do. Let's say the data is coming in some other format, it is coming in a JSON format or some other format of the data, and you want to convert into a CSV format before storing. So all these things you can do in pre-processing. Then finally comes the big data analysis. Big data analysis. So over here we will be analyzing the big data and we'll be getting some insights from the big data. We can visualize that thing, we can generate the report and so on. So basically we'll be analyzing this big data over here. We'll try to find some output from a big data that is coming, some reports or something like that. And finally, let's say whatever reports were generated, we will be doing integration. So we'll be just integrating with other systems to generate the reports for the internal business use, or it can be given for to the governments or the government agencies. The data can be sent to government or government agencies. It can be sent to NGOs, that are non-profit organizations. It can be sent to some authentication or public authorized system, whoever is authorized, and so on. So the data finally goes over here, and these all peoples can use the data. So this is the entire flow of data, how it flows from starting place where the data was either generated on real time or the batch using a batch processing. The data was either structured and unstructured, can be generated from bank, mobile devices, cars, aeroplane, IoT, and so on. Then it went to privacy when the data was encrypted. Then it went to pre-processing. Finally went to big data analysis where the insights were found out and given to a data integration. And after data integration, reports can be generated. The data can be forwarded to government agencies, to NGOs, and so on. So this is the data flow of a data. What is the difference between data analysis and data scientist? What is the difference between data analysis and data scientist? So typically the data analysis will be using tools such as SQL. They will be writing a SQL programming language or some other tools they can use. They usually use some BI packages, business intelligence packages. They find some intermediate statistics. But if you compare with a data scientist, they are more of involved in data acquisition. They will get the data, move the data, do data movement and manipulation. Instead of SQL, they will be using complex programs. So they will be doing some programming. And instead of intermediate statistics, it will be some advanced statistics. Moreover, you can also say that the data analysis is looking backward to get some insights, and data scientists can be called as looking forward. So looking at the previous data, it will try to predict the upcoming things. So it will be just trying to predict some future. Of course, it cannot be 100% guaranteed, but this can definitely help business to understand if something is going wrong at the very early stage. What are the roles that we can work on? The roles that we can work on as a big data after learning this, you can either work on as a big data researcher, can work as an architect, can work as a big data engineer, can work as solution architect, can work as Hadoop developer or administrator, business data analyst. It can also be architect, data officer, and so on. Basically, we'll be focusing on more on a big data Hadoop developer kind of role or a big data engineer kind of role or the data officer or a big this kind of role. And if you want, uh, you can also progress to administrative, you can also go into administration part, or you can also progress as an architect and so on, going forward. But the course is more aligned for a developer perspective. So let's see why there was a need of big data. We'll be taking a normal simple example, a grocery shop. So let's say you are having, there is a neighborhood grocery shop, which, let's say this is its grocery shop. To manage the things, previously it was just using a normal book. Then he realized that it is very difficult to manage using book, and he started using Excel. And he is very happy, and his business is growing fast, and his grocery shop is doing well. So he decides to open one more shop, and he implements the same Excel over here as well. And he's doing good, and his business is still growing, and the second shop is also doing well. He decides to open third shop. Now he finds some difficulty, whether if the person is coming to buy something in shop number 3, it is not available in shop number 3 but available in shop number 2, but shop number 3 doesn't know about it. So let's say, since his business is growing up, he also sets up some data warehouse, or some warehouse. So wherever the all the things he will be keeping, all the groceries will be coming from here, or you can also call it as a go down, from where all the things will be coming, all these groceries will be coming. Now he realized that he needs some software. So what he does is he buys some software, and he is using software, and he has connected it with the warehouse. So all these things are connected together, and he is very easily able to manage the things, all the items and so on. Someday later, he also opens one more shop, shop number 4, and he also connects with the same line and installs a software over here, and he is doing good. Now that his BNB brick and B&M stores are doing good, he decides to go online. So maybe he hosts some website, as well as he makes some mobile app and makes it live. So people are also shopping from here, and of course this also needs a connection to the warehouse or a go down. And by this way, more and more data is also getting generated with the increase in business, increase in number of channels. By going from B&M to online as well, the data that is getting generated has increasing. So all this increase in data results is, now that he needs some, the software is not so much capable that it can process this data, cannot give much of insight. So what he does is he decides to make a, or purchase a Hadoop system. So Hadoop is a distributed system. So let's say Hadoop is having multiple computers connected in parallel. Let's say he's having 4 computers connected in parallel, and this is the master computer that is taking care of all the 4 computers. So this is the Hadoop cluster. So this is called as a master, and you can call it as a slave. So it is 4 slaves connected to a master, and the data that was generated and coming over here, now the data will also go over here and will go into the Hadoop system for analysis. So this is a typical example wherein, as a shop grows, the data also grows, and there is a need of more and more complex examples, more and more complex things to take up with. So this is an example of how the data is growing. So that's it that I wanted to cover for introduction to big data. This is a very basic introduction to big data. So that's it. Thank you for listening to entire video, and we'll continue in the next session. If you're having any doubts, anything, what you can do is you can just post the question in Q&A, and I will try to answer it as quickly as possible. Thank you for listening. Thank you. Bye bye.